My name is Kirk Munro. I go by the handle Poshaholic. If you want to find me or email me, just go on Twitter, look for Poshaholic, or email me at poshaholic@gmail.com. I've been a PowerShell, and now Cloud and Data Center Management MVP for about 12 years. And I've been spending a lot of time in recent years working on serverless functions, both for just experimentation because I wanted to see what makes them tick, as well as for some production solutions that I was involved in. And I wanted to give this talk because this is one of those areas where you get into it and you're working in it for a while, and then you start learning some things about it that make you go, oh, and that you really wish you knew up front. So I wanted to bring some of that knowledge that I built up over about 2 years working with serverless functions inside production environments and share that with you, because some of the things I talk about, a good number of the things I talk about, aren't really explained well in documentation, and they're things that you need to understand when you're going to go and actually start working with serverless yourselves. This talk is a little bit outside of my comfort zone from what I usually do, because most of my talks are introductory slide, thank you slide, and demo, because I do a lot of talks just about talking about PowerShell. And when I'm PowerShell, I'm a hands on the prompt kind of guy. Let me run the scripts. I'll show you lots of code. I've done talks here about the PowerShell debugger, go into great depth on some of those topics. I'm a PowerShell maintainer, or not maintainer, but a contributor, and I work on the debugger and things like that in PowerShell core. And so I grok code really, really well, and I really enjoy that. And I often don't take time to do a lot of slides because it's just easier for me. So here, this one's the exact opposite. In this one, I actually don't have any demos planned. However, depending on questions that come up, I may go into a demo. And the reason why I don't have demos planned is because this is just one of those areas that, as I was talking about, you need to really know certain things up front. And when I originally proposed this session, I was thinking, okay, am I going to go and show a lot of demos about this, or am I going to go more on the theoretical side and talk about what you need to know up front? And I went the theoretical way because there are also 2 other sessions at this event, one that's specifically on AWS Lambda, another one that's specifically on Azure functions with PowerShell and the news that just came out yesterday. And so those are going to show you how to build those things out without talking about the things that you need to know about serverless and the things you should know up front before you go and choose what solution you're going to use. So with that, let me get into why talk about serverless in the first place. Yesterday, in Don's presentation, he was talking a lot about the tools in your tool belt and the kind of things that you need to be aware of, whether you have the tools that you know really, really well and the ones you're kind of familiar with. My goal here is that serverless is a great tool for your tool belt. It's one you're going to want to use because of the things it offers to you for DevOps purposes, for production solutions. It's just got a lot of powerful features that offer a lot of value. And by me covering this level of a talk at the architecture level, kind of talking about how things work, you're going to have a better understanding when you go to grab that tool, which tool you want to grab and start using it right away, the right way, and learn from the mistakes that I made. The way that serverless works, serverless makes it really, really easy to run event-driven workloads. That's why serverless exists. Actually, how many people in the room already use serverless? A good number, OK. And how many of those people it's using Azure Functions? With PowerShell? Using the experimental, OK? And for the ones that aren't, just speak up. What are you using for serverless today? OK. OK. And with AWS, are you doing PowerShell in AWS, or are you doing C# or Python? OK. Sure. OK. Anybody else? Lambda, yeah. OK. So I still think this talk's going to offer a good amount of value to you because of some of the things that you might not be aware of, depending on the solutions that you worked on. And so, but for those, you're going to find there's a fair amount of stuff that's familiar here as well, but that's fine. I'll just go through some of the low-level details so they can share them with the people who aren't necessarily familiar with them. So you can run event-driven workloads in a cloud. You can run them on a schedule. You can run them based on event handlers that trigger something. So maybe you want to run, well, solution I had to work with. We had a product that had we wanted to basically add PowerShell extensibility into the product. It was a cloud-based solution. We wanted to be able to have people write some scripts for that solution that then run and do something with that solution itself. We didn't want to stand up our own servers or our own containers and manage all that stuff to actually go through and run that piece. And so serverless was a natural extension for that. And the product already had capabilities when I started looking at this as an extension point. It already had capabilities to call out to some arbitrary REST API. But the majority of our customers weren't devs. They were people who work at a different level, and some of them do automation and scripting. And so PowerShell seemed like a natural fit. And so I decided that serverless seemed like a good approach for that solution because they could call into an Azure function endpoint, run some PowerShell, do the work there, and then and not have to worry about the glue because it's serverless. Not have to worry about all the details that are going on behind the scenes. The nice part about that is low cost, so it's often free to a point. But to a point is because the free solutions that are available have a threshold where all of a sudden they start costing money. But that threshold is fairly high. So for Azure functions, it's, I think, 1 million executions on the free tier before you start actually getting into cost. You can also buy into paid solutions because the paid solutions are more performant and give you some extra scalability capabilities that you don't get from the free tier. So they are scalable. It's a very easy way to build scripts that respond to events. So yeah, I mentioned our extension point. If you think about IFTTT or Zapier or any of the other solutions that are out there for doing basically mapping one system to another via REST APIs and making things happen, this is a great solution for that. An example, different from the one I just talked about. So there's the one that I was just referring to, which is basically an extension point. Another thing that I did with serverless with Azure Functions was we wanted to basically dispose our documentation model to customers, and we were using Markdown because we learned from Microsoft because I was working at PowerShell MVP, and Microsoft started adopting Markdown for documentation. Seemed like a great way for us to do documentation as well. Our original solution using Markdown was putting all of our content in GitHub so that anybody could basically do a PR and update the docs if they needed to, which was great. And we were just pulling the raw GitHub pages from the raw GitHub channel. Because GitHub there's a way you can just go and best grab a raw file and get the contents from it. That worked. However, we learned after pushing this in practice that the raw GitHub channel has a delay of up to 5 minutes if you do an update, which when you're trying to do docs and make things look right on a page and a layout in a product for customers, doing that update and pushing it into production and waiting 5 minutes or up to 5 minutes before you can actually see it and make sure it looks properly is just something that's not desirable. So we wanted to get rid of the raw piece, and GitHub has an extension API where you can hook into their, for example, like a commit. And so when you commit changes into your repository, grab that change set, and then do work with it. And so we decided to use Azure Functions. So the change happens inside of GitHub. The commit message or the commit event fires off into the Azure Function endpoint, which then calls another Azure function. And I'll talk about why that's necessary, getting into some of the details about why you need to think about serverless a fair amount. And so we call another Azure function, which would pull the documentation from GitHub, convert from the Markdown into HTML, and it'll be live almost instantaneous. So by the time you do your commit and you go and refresh the web page, you would see it. It was actually a really, really nice solution. And it's worked around that GitHub problem very, very well. Questions so far? No? OK. So when I first started getting into serverless, and I heard about the serverless solution, I really wished it was as easy as it sounded. I really wished it was so easy that you don't have to care about servers. And you can just take your code and throw it at the wall, right? And it'll just work. But doing that in a serverless platform without understanding what's on the back end, you guys probably know the idea of throwing something against the wall to see if it sticks, throwing a piece of spaghetti against the wall to see if it's ready and see if it sticks. Doing that with serverless, just throwing it against the wall to see if it's going to run and do everything that you want it to, I think it's more akin to taking your bowl of spaghetti and throwing it against the wall and seeing how well that works for you. So you really need to understand the technical details behind the scenes, because if you don't, you're going to be months into your solution and you're going to have that aha moment and think, I didn't realize that serverless meant that there were servers behind the scenes, and now I have to understand how those servers are running and what the infrastructure setup is like and the concerns that come along with that. So that's That's what I wanted to bring to the table here. So what serverless really means, it means your function's going to run on servers that you don't directly manage at a reasonable cost, sometimes even free, but in a very specific way you don't control, and that you can't get them to let you control, because I've tried. With some controls for doing scaling, and with limits that you can set on how far it's going to be able to scale, what's going to make it scale, and so on. There are thresholds that you need to think about in terms of time. There are thresholds you need to think about in terms of space that they're going to consume inside of cloud-based resources, and how the scaling is going to work. And you have to think about, based on the actual app service that it's running on, if you're running for Azure Functions, which one you choose is going to give you different levels of performance. And so if you're doing production and you want it to be snappy, what's that mean? And even with it, the snappiest solution that you can build, there are still places where it's not as quick as you want it to be, and how's that going to pan out? So this is going to expose that to you. So all the major cloud providers have serverless. Azure Functions has had serverless in 2 different versions. And so there's 1.x versions. I mean, it's all cloud-based services, right? But there's 1.x and there's 2.x. In 1.x, the 1.x runtime, that's where they originally implemented C# and JavaScript and F# and a bunch of other languages and PowerShell in experimental. And that's so if you look at the PowerShell version that's been around for a long time inside of Azure Functions, that's on the 1.x framework. The PowerShell announcement that came out yesterday on the PowerShell team blog, and they talked about with Joey at the session, during the sessions yesterday, that's on the 2.x runtime, so that's using PowerShell core. 1.x I should mention as well with PowerShell, it's Windows PowerShell. 2.x is PowerShell core, and that brings a lot more performance, a lot more capabilities for what you can do. It's a better platform, and it's a better implementation. Yeah, I'll go to go more in detail about the experimental PowerShell in just a second. So, and then there's AWS Lambda. AWS Lambda has support for, I don't think they have versions. I was looking for versions. I couldn't finally find versions. They seem to just have this Lambda solution that you can run a lot of different code, whether it's using C# or PowerShell or JavaScript or Python. Yesterday, Don mentioned having the right tools and the languages for your tool belt. There are cases where he downplayed the C# side of the fence. C# is a very useful tool for DevOps folk to have in their tool belt. And actually, just out of curiosity, how many people feel like they have a good handle on when they should use C# to as part of their PowerShell solutions, maybe for binary commandlets or just actually getting into that level of detail working in C# with PowerShell versus just doing everything in PowerShell? OK. A good handful, more than I expected. A lot of people don't get that at all when you should actually go to C# and when you should do your work in PowerShell. There is a talk going on next door that way that's being recorded with Thomas Rayner talking about binary commandlets, and it's being recorded. And it would be great for you guys to watch for the rest of you who haven't gone down that path, because understanding that's really useful, and that knowledge applies into serverless solutions as well, and other places where you just need to pick the right tool, right? Where we want to get the job done for the companies we work for. We want them to be efficient, and so you need to pick PowerShell might not be the right solution. C# might be the right solution. Maybe it's a combination of the two. That one solution I mentioned, the first one I mentioned, where we were taking PowerShell from our product and firing it off into a REST API to actually do some work. I actually didn't implement that using the experimental PowerShell. I implemented that using C# Azure function that accepted the PowerShell script that it would run because it was coming from a trusted source, and then it would run that through C# APIs calling into PowerShell to actually make that do the work. Google Cloud Functions, that's the one I'm least familiar with, and that's why I didn't include that so much in this talk, other than to mention that it's there. I only didn't include it because I haven't paid much attention because they don't have a PowerShell solution for their serverless yet. But they do have Python, they do have JavaScript, they have a bunch of other ones. And I'm sure that at some point I will start ramping up at that side of the fence and figure out of those 3, when should I use one versus the other ones? Because I don't think it's just always go with Azure or just always go with Lambda. I think you really need to know the tools and pick the right one for your organization. So PowerShell in Azure Functions. Experimental support was added with Windows PowerShell in the 1.x. It's been around since 2016, which surprised me because I didn't even hear about it until 2017, and there was a bunch of people who were already working on it, and so I started digging into it. And I very quickly realized that the people who wrote it aren't PowerShell folk. And so the solution left a whole lot to be desired, and that link, and this slide, I haven't put it up yet on GitHub. I will put it up on GitHub, and you will be able to find through the common GitHub repository that they have showing where all the slides are and all the files are for sessions. I'll drop a link there so you guys can actually go and get these links if you want to go read up on it. But there's a long post there from me talking about why their design's not optimal and the things that they should consider doing to fix it. And we had numerous discussions over the years, and I started carrying some of that plus my experiences to try to drive to try to help influence the Azure Functions 2.x PowerShell core implementation so that they don't make the same mistakes and so that they work through some of those issues. So it's great that they started doing the PowerShell. I was really, really happy to see it. But yeah, it really wasn't a great implementation. So that pushed me into writing it in C#, my solutions in C#, and invoking PowerShell because, well, one, I was working in production. The PowerShell one was clearly marked as experimental and not supported. C# was supported. C# you can invoke PowerShell. So I just put the two and two together and did it that way instead. So I had a technically supportable solution. Plus, I worked around a lot of the issues that they had in the original design. So that's one that's available to you today. The new thing that just came out yesterday is in preview. If you can't use preview, you might want to look at the C# one if you're really itching to get going and look at writing a function in C# and just invoking PowerShell via the PowerShell API. Or you can just tinker with the PowerShell 2 preview stuff, and that might float your boat and do the job that you want to get done. But both are worth understanding and trying to figure out which solution is going to be needed for you. I actually haven't figured out, because the 2.0 stuff is so new, I haven't figured out if it would work for some of the stuff that I implemented before, and I think that based on experience of working with C#, I would probably tend to still like that as a solution for reasons of performance and production environment and getting the job done quickly and having a bit more control over how things are invoked. But I may be mistaken over time as I dig into that in more detail. It only just came out, so I haven't been able to spend that much time on it. So yeah, the 2.x runtime public preview yesterday. There's a dev blog out on it. I read it through it last night. It's a great dev blog, goes into lots of detail, and really explains what this is all about and gives you, there's a link to a tutorial, and the tutorial is actually very comprehensive. I went through it last night, and actually it's a great starting point to just getting into Azure Functions and PowerShell. So I encourage you to take a look at that as a resource. Now, the architectural details in Azure Functions are where the term serverless starts falling apart. And you really need to, well, I should say in Azure Functions. It's Azure Functions and AWS Lambda. There's the architectural details behind serverless. You need to know what's going on to choose the right solution. Functions that are invoked in a worker process. So the way this works, let me back up a little bit. You have this endpoint, right? So in Azure Function, all it is an endpoint. And that endpoint's going to be invoked on a schedule. And the way that happens is by you having a scheduler inside of Azure that actually just fires it off internally, implicitly, because you can create a scheduled Azure function. So you don't have to do the scheduling management. It just runs on a schedule. Or you could make your schedule work from an outside scheduler that fires off a call via REST API. So you have this thing. It's going to run and do some work. And the way that's going to run is your request comes in to the Azure Function runtime. The Azure Function runtime looks at the function that's being run, grabs this package, the payload of the work, fires it off into a worker process that's running on some virtualized infrastructure somewhere, and the worker process does the work, and the results go back. There's a lot of moving parts there. It's not just as simple as I just want to run some code, and it's just going to run. And the fact that it's a worker process is interesting because up front, you may think, oh, that's great. I'll be able to fire off a whole bunch of these guys, a whole bunch of different processes. Everything will run just fine. But the way the Azure Function implementation was done is they actually want, because of performance, and I get why they did this, because they wanted a highly performant solution, they use their workers as much as possible. So you have this virtualized infrastructure with a worker process that's running. It's running one function. Another invocation comes in, concurrent, while that's one running. Azure looks and checks the load and says, well, that process can take more, so run that function in him as well on another thread. And it'll continue doing that until the worker process is carrying a certain amount of load, at which point it's going to fire off another worker process, and that'll start doing functions on another thread, and so on. And so you end up having a multi-process, multi-threaded solution running your work behind the scenes. But PowerShell was not implemented for, I don't want to say it wasn't implemented for multi-threaded use, because behind the scenes threads get used. People do use threads. There's modules out there that people can run threads into PowerShell. But a lot of modules that are written today aren't designed for multiple threads at the same time for concurrent execution. You can see that, simple example of that, if you go into PowerShell ISE, and this is one case where PowerShell core is not going to solve it, at least not as far as I know. Please correct me if I'm wrong. If you go into PowerShell ISE, you can open up multiple tabs, and each tab has a separate run space. Each of those run spaces is basically running on a thread inside of the same process. If in one run space you connect to Azure, and you start working with Azure, and then you hop over to your other run space, and you start working with Azure without connecting to it, it'll just work because of behind the scenes how the Azure module is written and how it stores your connection inside of process-wide static variables. That information is accessible to any process. So your second run space, you go and try to create a new virtual machine without connecting. It checks and see, oh yeah, I've got this connection already. I'll pick up on it and use it, which is helpful in some cases, but challenging when you don't want that. Challenging when you're dealing with multi-tenancy. Challenging when you don't necessarily want to share information from one Azure function with another. And so you need to choose the appropriate solution, the appropriate at-service plan. So in this case, yeah, managing concurrency, requires choosing the appropriate app service plan. And if you're using PowerShell core, you need to set a maximum limit on the number of concurrent invocations. That's slightly different. I was getting ahead of myself, so I'm just going to go through this point really quickly. PowerShell core and Azure Functions by default can run a function, and then you can run another function, and then you can run another function, and there's no concurrency built in the preview today, except that you can bump that limit up so you can do some concurrency. But they reeled that in because of this problem of the fact that some modules are not designed that way. Some PowerShell solutions aren't designed that way. And so when you do multiple invocations, you deal with things like the third point here, race conditions, cache credentials being bled from one run space into another, and otherwise your scripts walking over one another. Yes?
One common problem with that is multiple versions of the same DLL that you're using as independent.
Right.
Use of JSON, for example. If you've got different modules that use it, different versions, then multi-threading will completely crash on you.
Yes, that's right. And you also see cases where you might have, when you're dealing with Azure Functions or you're dealing with serverless, whether it's AWS or Lambda, if you're dealing with, I should say Azure Functions or Lambda. When you're dealing with Azure Functions, you have an Azure Function app. You have multiple functions. PowerShell supports the notion of side-by-side versioning. You have things running in the same process at the same time because of concurrency. If one of your functions loads a particular version of a module, and then your other process tries to load a different version of the module because of the way you've written your functions, and they're all inside of the same space, same shared processes, that's going to cause you problems because you can't unload DLLs and reload the other DLLs, and they're both running at the same time, and how's that going to work? And .NET doesn't support that. Well, there's ways you can unload DLLs, but it's not in the Azure Function runtime today. And so whether it's dealing with the DLL issue because you're dealing with multiple versions, or whether it's dealing with multi-tenancy because you're working with different, you might not be a multi-tenant provider. You might just have multiple Azure subscriptions in your organization and trying to run from one Azure Function solution against multiple subscriptions. You're going to run into problems that are going to have your scripts walking over one another, and it's very hard to figure out what's going on after the fact. It's very hard to figure out when those errors come up, where's that error come up, because it's going to happen based on a point in time and what was running at that time and who walked over what, because it's all in the same process space. But it's serverless, right? And so you don't have to think about those things, but you do because it's a serverless, but you need to understand exactly how that server was implemented, exactly how it's running your stuff, and then make sure that your stuff is designed to run with those constraints and with that design in mind. There's actually a lot of PowerShell modules. I mentioned there's actually a lot of PowerShell modules that use statics, and that's just simply out of, in my opinion, out of a little bit of laziness and I guess not understanding PowerShell run spaces. I wish that PowerShell had a solution. I wish PowerShell had the notion of run space level storage. Like there's thread level storage inside of .NET where you can have storage of some credential inside of your thread, and it's not going to bleed into another thread. But thread level storage isn't good enough because run spaces can contain multiple threads, and so I wish there was run space level storage. That doesn't exist today unless you specifically implement your modules that way. And so it's possible to do, but it's more work. You need to think about it. You need to understand multiple run spaces. A lot of people don't because most people in PowerShell haven't used multiple run spaces, and so this problem was carried into the Azure function implementation. So it's fine because they're very performant and they work really, really well as long as you know about these constraints and design your solution appropriately. One way you can actually get around these things is by creating different Azure Function apps, because one Azure Function app can contain as many functions as you want. But if you're going to run into some of these conditions, some of these issues, create a second Azure Function app, because your Azure Function apps are going to run on a worker process, but you're not going to have, and they're going to share the same process space, but multiple function apps are not going to be in the same process. Each one's going to have their own. The invocations of the functions inside those will share a process, but invocation from Azure Function App A and Azure Function App B will not be in the same process. So you can work around it through design, which might require some, I've done this with the production environment I was talking about before that I don't have access to anymore, where we had different Azure Function apps and I had to copy some code between them and everything, and so I don't like copying the code, but it solved the problem because it kept the things isolated from one another and allowed us to do multiple tenant work. I mentioned PowerShell ISE. Oh, yeah. And so aside from understanding the details for Azure Functions and how they're implemented behind the scenes, you also have to understand the details of all the modules that you're using, and even the APIs that you're using. Because depending on what API or what module you're using, I mean, the API might not be designed properly for concurrency in the way the Azure Function runtime is going to use it. So pay very close attention to how they work. Read the source code if they're open source. That's one benefit of today. There's so much open source out there. You can just go and look at the open source and see, are they using statics and do they have these kind of problems? If you find that, please give the feedback to the team who actually has implemented that solution, saying, hey, this is kind of an issue because of Azure Functions and because of multiple run spaces in PowerShell and trying to get everything to work properly, and that's a real challenge. And also read the docs, and the docs are pretty good for some of these things, but not so much. I mean, because even if you read into docs on the AWS PowerShell solution and how they work when you're doing credential management, they try to make it very easy for scripters. They try to make it very easy for ad hoc work, so you can just get stuff done, or for running some script so you can get some stuff done. But they're thinking in this easy solution that they're implementing, they're thinking one-off. I'm just going to run this script. It'll go and do the work, right? I'm just going to go and do some ad hoc stuff and get something done inside of my infrastructure, and it'll do the work. They're not thinking in terms of concurrency, because just concurrency has not been a PowerShell topic that's really surfaced much yet. A lot of people don't think about concurrency. They haven't had to. But you do need to think about it. And actually, it's becoming more important because there's things happening in PowerShell core related to concurrency. APIs are being exposed. So just make sure you read the docs. Ask the right questions. Go into the GitHub communities. Ask questions to the teams. The teams have been very helpful to me in this area. And again, running tests in PowerShell ISE, because you can find problems there early. So if you're not quite sure, just open up multiple run spaces in PowerShell ISE, connect to service A. While you're connected to that service, go into your other run space, see if you can actually do work. You shouldn't be able to if you haven't connected there, right? Because it's a separate run space if things are designed properly. If you can, the caching that's going behind the scenes, is it caching in memory? Is it caching on disk? That kind of stuff is really important. Actually, the disk one's actually a good point too, because with serverless, you have access to certain things you can do on disk, but other things maybe not. And so not everything is actually going to run in a serverless environment, depending on how they're working with files on disk. So yes, make sure you ask the right questions and do the research to understand it. Even more details that come up and bite you. So functions are launched from one of three states. There's cold start, that's the slowest. When you deal with the free tier, The free tier is always on cold start. So your function package is going to deploy on the worker agent when you invoke it. And then it'll load into memory and then run. And so it takes some time for that to happen. And if it's running and you run out and you invoke again the same free tier, again, the load balancing is going to figure out, OK, I've got this thing running. I can fire off another stuff. And so it'll work fairly good. But very, very, very quickly, there will be a timeout where you stop using it. I think it's 10 minutes. I have to double check on that. But I think it's 10 minutes for Azure, where it's going to say, OK, that agent's not being used on the free tier. So I'm just going to tear it down. And then you've got a cold start again, which may be 2 minutes, depending on what you're doing. It may be longer. It can take a while, depending on how many modules you're loading and how much work your package is doing for it to actually get up and start running. Question?
Actually, the numbers they mentioned was 10 seconds plus import time whatever resources you use.
10 seconds? OK, before they tear it down. OK.
Cutting down cold start was like the priority number 1 and the very well developed version 2 of Azure Functions.
OK. Thank you. So they tear it down as quickly as possible on the free tier. They also, the free tier is kind of funny because if you talk to the people behind the Azure Functions, the people who work on the team about the free tier, some of the people work around this problem by creating an Azure function called init that does nothing, and they just call it all the time. And the team knows about this, and so far they haven't really poo-pooed that as a practice, saying you shouldn't do that. They're saying this is the way some people work around that problem, and they keep it live. It's getting them, the benefit they're getting is learning how people are using Azure Functions and getting traction and mind share and growth. But that's not going to, I think, long-term scale as a solution. And so when you really want to get into performance, you want to get into faster starts. And the way you get into faster starts, so a warm start is where your package is already deployed, and you fire it off, and it just runs because it's already there. You get that by picking the appropriate app service plan. And there's different ones you can pay for. They give you different levels of capability on the back end. So you do this, and I did this myself. We switched over to paid app service plan. We switched to one that actually had a decent number of cores, good amount of memory, was very performant, was running our stuff very snappy. And then I started looking at the data, because the runtimes, they actually do track every single function, how long it takes to run from start to finish, and you can go through and look at that. And I was seeing, yes, performant, snappy, 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 snappy. Oh, why did that take 3 minutes? And when I dug into it, I realized, after talking with the team again, and they don't talk about this too much, warm start isn't necessarily warm start. Warm start's more lukewarm start. They still back off and tear stuff down, even though you have an app service plan where you set things up as a warm start. If it's idle for long enough without use, maybe in the middle of the night, based on time zones, what's going on with your service and so on, they will leave the function package deployed, but they will take it out of memory. And PowerShell module loading isn't the fastest thing in the world, right? I mean, you guys know that. Sometimes, depending on the packages you're loading, depending on the dependencies, it can take a while for that stuff to fire up. And so if they've gone through and pulled it out of memory, your invocation is going to come along again, and you get that stall and wait for it to happen. And that was challenging, and that was one. I didn't come up with a solution for making the warm start work proper, other than going with what the cold start folks are doing, which is having an init function. And so just constantly pinging it with an init that doesn't do anything, just to keep it loaded in memory, because you're paying for the app service plan and you want it to run, and that was the only way I could find around that. I wish there was a better solution. I mean, if it is lukewarm start, I wish it would document as lukewarm start and then actually have a warm start and different pricing, so you can actually get that if they don't want to give it to you, for what you're paying for the app service plans that are available. But they don't, and so it is what it is. So you have to understand these things when you're dealing with production, because we had, the solution I was using, we had thousands of customers, thousands of functions being invoked per day, needed to be very, very snappy. And the first thing in the morning, when that would come online based on the time zone where the service was running, you would see those first hits, and they would be slow and not as performant as you wanted to, and not the experience that we wanted. And so that's the kind of, you got to be aware of how that's going to impact your performance inside of a production environment. I talked about the app service plan. And the app service plans also give you scale configuration. You can scale up and out. You can do it based on thresholds, like when the CPU hits a certain percentage, fire off another agent, so it's ready for taking more load. So that you can actually manage that in more detail. You can fire off multiple agents. So you can have a lot more control depending on which app service plan you choose for scaling. And there's just basically some sliders on how I want to scale up versus how I want to scale out. inside of the actual the web UI. Always on doesn't really mean always on. You can read about that. So there's a discussion with the team between myself and the Azure function team about that, where they talked about the loop warm start, where I kind of found that out. And then the cold start thing I referred to, this link here talks about strategies for improving and eliminating cold starts, and that's where it gets into an init function and ping and so on. And there's some other things in there as well. And so depending on what you're working with. I mean, some of these things, really, for what you're working on, some of these things might not matter. Because for what you're working on, if it doesn't have to be the most performant, but it just needs to get the job done, then great. Azure Functions is a really, really good solution, and Serverless is a really good solution. But if you do need the performance and you do care about it, make sure you understand this up front so that you're going to aware when your performance does matter what you need to do. More details. So it's serverless, but you're responsible for building the package with Azure Functions. You're responsible for building a package that's going to be deployed into the agents and making that package available into Azure. Excuse me. And with the 1.0, the 1.x runtime, you had to do that yourself, load it up into an Azure storage. Excuse me, into an Azure storage environment, and make sure that was available. With Azure Function 2.x runtime, there are commands you can use to fire your stuff up into the cloud and make sure that's available. But you are responsible for that. How you load the package depends on the type of the function that you are deploying. So whether you're doing a C# function or you're doing a PowerShell function, how you set that up. If you're using the PowerShell 1.x stuff, which is experimental and not recommended, that had to be deployed a certain way, and you had to put your modules in a certain place and dot some I's and cross some T's to make that stuff work. C# is different. C#, you can identify the NuGets that you're going to use, and it'll pull them down and make those available on the system. But you need to understand how the dependencies are working and how things are loaded into your memory. Lambda. So Lambda, there are less architectural details. I mean, I just went through like 4 slides talking about the AWS, or about the Azure function stuff. When I get into AWS Lambda, there are less details that you need to be concerned about because Lambda's implementation, they do use separate process space. So every Lambda function that you invoke is in its own separate process, which they refer to as Lambda compute environment. So that's great. You've got process level isolation. Concurrent invocations, they're just going to fire up an additional compute environment and another process, so you're separated from one another. No problem there. It's more expensive to fire up those environments that they're doing because they're not leveraging in-process concurrency with multiple threads, so you will see a performance hit because of how things are, well, depending on the timing of when you run your functions and so on, because of warm starts and whatnot, and because of how you can configure the system. But it is potentially more expensive to actually spin that environment up, and so there's an issue there. And there's a good doc. I got a link at the end of this actually talking about performance between the various environments and the concerns that you might want to have around that. Invocations for AWS Lambda, they work with a temp folder on the local file system. So you need to know that. I mean, normally you wouldn't care, right? So you're thinking it's going to spin up a commute environment, and it'll run the process, and it'll do the work, and if it works with temp, that's fine, and then it goes away, except that subsequent invocations will reuse existing compute because they're trying to deal with performance as well, right? Serverless, we want it to appear that you don't have to care about this stuff. We want it to appear snappy, and you can just throw your bucket of spaghetti or at the wall, and it'll just work. But they are going to reuse the compute environment that was already there. So if they're going to reuse the compute environment, then if you did do things with temp folders, or if the PowerShell module that you were working with happened to work inside of a temp space and write some configuration there, and then you come along and you run another one, and it picks up on that configuration, well, what's that mean? Are you going to pick up on credentials that were cached to disk? It depends on what you're working with. It depends on the modules you're working with and how they built out their solution. So you still have to look at the code and understand the implementation for what you're using and map the two together to make a solution work. PowerShell Lambda function support requirements. I actually like their solution better. The way they do requirements, and by requirements I mean like modules, is you actually just use a require statement inside of your script, and AWS Lambda will take care of building your package based on what your function has And so you don't have to worry about the details behind the scenes of where do I put this bundle of modules so that it's going to work and so on. They actually just handle that for you. And so that's a bit of a nicer solution on their part. Other important details for all the cloud platforms. So when you're working with event-driven APIs, you need to understand the needs of the caller. An example of that, I mentioned GitHub, and I mentioned when you're dealing with the GitHub event-driven API, and you've got a commit, and you want, based on when I do my commit, you want to do some CI/CD work and call into some Azure functions. GitHub expects you to return your result of that API within 10 seconds. And if you don't, it considers it failed. And so what are you doing when your commit happens? You're going to go and grab your code, and you want to go and deploy this package and maybe stand up a web service that's not there and put it into a test environment and so on. All of that may take time. So how is that going to work if you have to respond back within 10 seconds? Well, you might have to use multiple Azure functions. So you have one Azure function that takes your GitHub commit message and puts it into a queue and says, OK, I got to process this, and returns back and saying, yeah, we got it. And so that can happen very, very quickly, and that's what I ended up doing. I ended up using an Azure queue to store my incoming GitHub requests and quickly grabbing the details, which was taking microseconds, and then firing back saying, yes, got it, yes, got it, yes, got it. And then another Azure function that would fire up based on, oh, there's new messages in the queue, because you can fire these up based on all sorts of things. And so you get this message queue. Oh, look, there's something there. I've got to go and process this guy. He could take all the time he wanted within the constraints of how long the Azure function can run. Actually, I didn't mention that. So you can run serverless functions for a period of time before they will be considered timeout. By default, with the V1 runtime, it was 5 minutes, and then it would time out. You could increase that to 10. I think, if I recall, it was 10 on the free tier. And if you get into the paid tiers, you could bump that up a whole lot. You could go into an hour and have a lot longer running function. Yes?
So does that time start, does the clock start when it starts spinning up the environment or when the code starts running?
That's a great question. And I'm trying to think back to the data that I was looking at, because I looked at so many timers and results. And I'm pretty sure it's from the moment of invocation. Yes?
Yeah, it's not totally deterministic, so I think you get 5 minutes from the point of the invocation, but then after that, it's like not a guarantee that those extra minutes are going to happen.
OK.
I think the point is that it's probably, the question's probably not relevant. Like you can count on the 5 minutes, but maybe more than that.
OK. Thanks, Joey. And actually, since you're here, with the 2.x runtime, are the limits the same where it defaults to 5? You can bump it to 10 on free, and you can go higher on higher app service tiers?
I believe that's the case, yes.
Yeah.
We may have even been up a little bit more, but we're pushing premium really hard now.
Yep.
Which is like you don't have to manage your app service instances, but you still pay for one, and then we like auto manage you up.
OK.
More app service instances, like just for a fixed cost. So it's kind of a best of both worlds.
Yep.
But it is premium in both name and price. So.
Got it. Thank you. So understand the limits and understand the needs of the caller. You can still build great solutions. And you'll hear about this thing called durable functions. And durable functions are an interesting solution that's available in the Azure function runtime to be able to do some longer running solutions. However, durable functions aren't supported in the PowerShell 2.x stuff that came out yesterday yet. But they are in C# and so on. And so you can read up on that, and you can go the C# way or Python or something else that support durable. I don't recall if Python supports durable or not. But anyway, you can go that way if you need to using one of the other languages. Or you don't necessarily need to use durable. You could be creative with things like message queues and just having one function that then passes off the processing. Thinking more in terms of PowerShell and pipelining, right? I mean, that's how my head thinks about these solutions. You've got this guy that receives a request and says, OK, I got it, pass it off to the next, and then go for the next request. And so that next guy is going to take it and run with it and do what he needs to do and pass it off to the next guy and so on. So you can use a multi-tiered solution that handles things very well, even though you don't have durable in the PowerShell function runtime for the 2.0 or 2.x. So that's the message queues comment. Yeah, time limits, storage limits. So there are storage limits on some of the cloud platforms and how much you can actually put inside of your bundle. And so you need to think about that and make sure you know what those are. Things like the time limits you can increase directly yourself. Storage limits, I think, depending on the providers, actually, maybe for time, you can reach out to the provider and have them increase the limits where they are going to bump things up for you so you can do more than what's there by default. And so just plan in advance. Some of these requests, by the way, you really need to plan in advance because some when you're dealing with limits inside of cloud, it can take a very long time for the cloud provider to actually give you that bump up in the limit, depending on what you're requesting. Because they're still dealing with the constraint of, I have a pool of resources, and if those resources are all being consumed, and you're asking for more resources in a certain region, and they might say, well, right now we don't have the bandwidth for that, so your request is going to be fulfilled in 30 days. And so you need to switch to a different region. And so you need to plan ahead and make sure that you can get those limits up early for the solutions that you're going to make available so that you don't run into that heavy delay. So that's all that. So there, I mentioned there are 2 complementary sessions where you can learn more, and these ones are going to have more on the actual demonstration side. So unleashing your PowerShell with AWS, Lambda, and Serverless. That one's an hour and 45 minutes. Where they will show you the implementation. There is a great, and actually with this one as well, there is a great demo. Just one document, one pager. You just go through it on their website, walking through, I'm going to deploy my Lambda solution and see how that works with PowerShell, just like there is one for Azure Functions. And so I encourage you to go through those. They're really simple. I didn't want to just, I was thinking, do I do a demo and just go through that stuff myself? But they're so simple. You're going to learn more by doing it than by seeing me show you some Azure function that's up there, because an Azure function is just a blob, it's just a chunk of code that's going to do some work. And from my perspective, the introductory stuff is more about the details of how that does work and how do you set that up properly to do the work you need that I wanted to cover here. PowerShell and Azure Functions, that's Joey and Dongbo on Thursday. And then additional resources. So there's actually a really good amount of documentation on these things. The documentation doesn't necessarily cover some of the stuff that I talked about here, so I'm happy that you guys came to hear me talk about it. And that's pretty much what I have. And I know I'm finishing early, so I can take questions. I can go to deep discussions on some of these things. And I'll also be around for the rest of the week if you want to have sidebars and talk about stuff that you're using with, or things you're thinking about using with serverless and see where that goes. So thank you for coming. I hope this was useful to you. Some of these things I know are at a depth that you might think, well, I'm not going to care about that, but you might not care about that until you do. And so hopefully, hopefully this does come up and save you from tripping over some of those things that I tripped over in the solutions that I was putting out. So thank you.